My name is Kyle.
So today we are going to present the PPT on mathematical modeling of aircraft wing. So the aircraft wing, the question given is 5.8 shows a simple mathematical modeling of a cross-section wing area for a small remote controlled aircraft. The model consists of f of x and g of x enclosing a cross-section area of a wing. The two curves are symmetrical and mirror images of each other. In a horizontal symmetrical axis, the group of scientists who model aircraft being placed in a physical model in a coordinate system and measure the coordinates of upper curve. These coordinates are given in table 5.5. Based on the principle of aerodynamics and approved industrial specifications, these groups are known that a good wing shape is given by the equation f of x is equals to under root x plus bx plus cx square plus dx cube plus ex raised to 4. So here in this question we have to find the constants a, b, c, d, e and we have to calculate the cross section area of the wing.
Introduction about the question is aircraft wing is very important because the generator leaves and the shape of aircraft wing is called an airfoil. It is must be smooth and aerodynamics for a better performance of aircraft, and engineers use mathematical model with cross-sectional area for the given equation and its calculating cross-sectional area. Problem statement is in this problem we want to model the upper curve of the wing using the given equation. The equation is f of x is equal to 8 under root x plus bx plus cx square plus dx raised to 3 plus x raised to 4. And the a, b, c, d, e is constant and we want to find out it, and then we found the 5 equations. Then we calculate the cross-sectional area using the given equation and integration. This is the provided data, and x is, and this is the y-axis and this is the x-axis. And the x is position around the chord, and y is the height of wing surface above the chord line, and both is given in the meters.
To find the constants A, B, C, D, we use this curve fitting method. In this method, we submit our data points to the equation and solve the equation with the help of Python program. Computer calculates the value of A, B, C, D, E and plot the graph. The graph is matched to the wing shape, and then it's calculate the cross-sectional area. In this slide, we can see how we calculate the cross-sectional area. Basically, wing shape is symmetrical. That's why we take upper and lower curve to find the area. To find the area, we use formula A area is equal to 2 into integration of 0 to 1 f of x. In this slide, we have to calculate to mathematical model of a wing. We use function of f of x is equal to a raised under x plus bx plus cx square plus dx cube plus e raised to 4. We choose this function because it is a combination of under root and square root and polynomials. It is flexible for to calculate the symmetrical cross-sectional area. We use the formula to find the cross-sectional area. 2a by 3 plus b by 2 plus c by 3 plus d by 4 and e by 5.
In this slide, we see the integration of the given equation is equal to integration x is 0 to x max 1. F of x is equal to 2a under root x plus dx plus cx square plus dx cube plus dx raised to 4. And integration f of x is equal to 2 divided by 3 x raised to 3 by 2 plus by 4 x raised to 4 and d by 5 x raised to 5. And what the formula of area is 2a divided by 3 x raised to 3 by 2 plus b divided by 2 x raised to 2 plus c divided by 3 x raised to 3 plus d divided by 4 x raised to 4 plus e divided by 5 x raised to 5. And we put the a b c d e values in formula of this one area, and we got the answer of 0.0684, and this integrated from 0 to 1 we get 0.0684 meter square of one side of wing, and the total area is 0. We calculate the half section of the wing, and this is 0.0684 meter square, and the whole wing's area, cross sectional area is 0.01368 meters.
So, final results, we got the constants A, B, C, D, E with the help of the graph, and we found the cross-sectional area of the wing, where A is 0.0316, B 0.1487, C minus 0.2812, D 0.1833, and E minus 0.0521. And the cross-sectional area we got is 0.137. So here is the conclusion. Mathematical modeling matches with the experimental wing.